On top of the issues that I've already identified regarding the correlation coefficient, that is, that it is mainly based on the amount of variance of the data that is explained by the regression line, and less so related to the slope of the regression line, there are other issues that we need to take into account. And because of these issues, it is very important to plot the scatter plot to identify these issues. This information is not given by the correlation coefficient. So, one issue is the issue of range. Let's consider this case in which we've got as the y variable the chess rating of chess players, and on the x-axis the hours of practice or accumulated hours of practice, and we've got there a positive correlation. Now let's consider that instead of obtaining data in a range of levels of chess rating, so a range of levels of expertise, we decide to conduct the same study but only with top players who are in the top range of chess skill. So we ignore the participants with less than 2,200 points of ranking, and we only consider the ones on top of that value. Now, when we consider those participants, the correlation almost disappears. So, by restricting the range of the independent variable here, or one of the variables, when we obtain a correlation, the correlation that exists in the whole range of values, it disappears. So always consider what's the range of possible values that you are considering in your variables. Non-linearity is a very important issue. You can obtain a line here that will be close to a correlation of 0, but it doesn't tell you anything about the structure of the data. Here, with a correlation of 0, it could be that there is absolutely no relationship between the two variables, but in this case, there is a relationship. In these variables, degree of effort and years since starting working, the degree of effort diminishes up to 3 years after starting working, but after that the degree of effort increases. So there is a relationship between these two variables. That relationship is not captured by the correlation coefficient, which will be 0, but because it is a non-linear relationship. We need a curve rather than a line to reflect the structure of the relationship. Another issue is related to heterogeneous samples. Here, if you consider the red values and the black values as part of the same sample, so basically you don't differentiate like it is in this graph, then the correlation is very, very low correlation. But when you separate into two groups, let's say could be that the black values correspond to adults and the red value corresponds to children, or it could be the case that it is male and female, or any other two groupings that are relevant. Now we see that the relationship between the two variables is very strong when we consider the values in the black group, but it's not strong at all. It's very weak in the red values. So we need to consider whether it is important to identify those groups as if the groups are relevant and it is clear that the relationship is different in the two groups, then the results may have to be reported separately, and we have to conduct two correlations instead of one. The last issue is the one related to extreme values. Here we have the relationship between two variables, and we've got a small but decent correlation of 0.22. But if we add one extreme value, this small correlation may become a very, very large correlation. So this is the same values as before, with the addition of only one value that is on the top right. And because of that value, the line changes completely, and now the correlation becomes 0.68 instead of 0.22. And that is due to only one, or it's all explained almost everything by only one participant. In this case, it may be reasonable to eliminate that participant for the calculation of the correlation coefficient.